Today I look at 4 gum stick storage devices, which are really NVMe M.2 form factor SSDs. 512 gig 950 Pro and 3 128 gig SM951s for affordability there. But also decent speed. They're all not SATA or HCI. They are all NVMe devices, all 4. And what do you do if you have a server that has only a spot for 2? One on the motherboard, that's an M.2 slot right there by my thumb, that connector. Goes across here to this metal post at the other end. There's the screw. And we have a PCI slot where we can use an adapter like this, which was around 20 bucks. And move it to the right post. This is 2280, the common size, but there's also 22110 for some new ones. For things like vSAN. Now I put some transparent, semi-transparent kind of smoked tape to cut down on the ridiculously bright LED. But this little device works just fine. And installing the 950 Pro on it actually looks kind of cool because the sticker's actually right side up in the system. So looks lovely in the server unless you have a second SSD. Speed is the same as on the motherboard. It's basically just a pass-through device. You can see this from the wire traces. Alright, so you're getting over to the first pins in the PCI bus. So you need a PCI 3.0 motherboard with 4 lanes at least to get full speed. I have a bit of a surprise for you. I'm going to hold at the end in the FedEx box. But let's get into this approach to an adapter with a little more cooling. So this is called the Wings PX1 by Angelbird. I've not opened this yet. So notice what it says, PCI 4 adapter. Alright. Looks like a couple of thumb lifts on the side here. Get this open without ripping it. There we go. Ta-da. All right. Activation now. All right, so we've got some thermal pads here. So that's going to be probably warranty voiding kind of work if we go ahead and go forward with this product. Open this up. Wow. Very good looking device. All right. And there's the back. And we have some flow through going on there with the design. Full height does not appeal to me much. There's nothing else in the box. So, okay. Well, it's a bit of an issue. In my case, I would have to steal off of another device like this one. There's a lovely back plate. Excuse me. That sounded worse than it was. There's no scratch there, don't worry. All right, just moving the backplate over, but then you don't get the airflow. So that's a little odd right there. I would have much preferred if there was half height in there. So for me to put it in this system, I will actually need to remove that. All right, so this video is really just a quick overview of different options for putting multiple M.2 gum sticks in a server. They do want me to visit the instruction manual online. What I'm looking for right now is how to open it, and there's the tool to open it. So I do want to show you the inside. And let's see if we really need an instruction manual. Alright, simple enough. Make sure I don't strip anything, give it a nice bit of pressure. That was really easy. So it didn't take much to get that threaded screw out of there. Wow. So it's a lovely looking device, even prettier on the inside. And, well, passive, right? There's no fan here. but heat should dissipate across this whole surface, and that's because of the special thermal pad that's going to join the SSD, in this case a sticker. Let's try this. So take the SSD, and it's keyed to go in this way. Okay, 2280 length. It lays down. I haven't decided yet if I'm going to do this, especially the warranty implications. But it would be fun to see the temperature reduction, although many people have already kind of blogged about that and tested that. So, all right. So you can imagine the other side is going to be stuck on here. You close it all up, and you're now adding a nice giant surface area to dissipate that heat instead of a tiny hotspot. Now you already have video of a FLIR thermal camera showing how warm it gets right around here where the controller is. Okay, so I'm going to set all that aside for a different day. And just move that off camera, put that box back together, and move to the last product today to show you would be this FedEx envelope, but I haven't yet inspected the contents or opened the contents, excuse me. I'm in a company called Amfeltec. Did I say that right? I don't know, but hopefully the inside of the box will kind of help us out. It's a Canadian company, and this is a pretty special but pricey device. So you're about to see the company name. It seems like I probably said it right. Here's the product name. Squid. 16. Why would you do 16? Well, wait till you see what's inside. This is pretty cool. At least should be. It's probably not going to look as pretty as the last item you just saw, but I think you'll get the gist of it very quickly once I open this. Yes, I know I don't have electrostatic wrist dissipation on, but it is a rather humid day. I'm not worried about that. Nice. So this is your first look at a pretty impressively designed device. I saw it on the web and like, ooh, this looks interesting. Okay, right away we've got some ceramic or something on there. Now, you don't need bifurcation. This is not splitting PCIe 3.0 into 2 channels or anything, but it is doing some sort of controller here to share with 4 devices, 2 in the front and 2 in the back. So there's the surprise. Now I have a way to get 5 NVMe devices in my little Xeon D. 1, 2, 3, 4, and the one on the motherboard that I mentioned earlier. All right, so I would need to go ahead and put all the SSDs on there, which, wow, those are finger tightened at the moment. It's interesting. What do we have in here? Heatsink installation on the modules. It's very important to avoid overheat. All right. So these are heat sinks. So a nice little bonus would be, what if I stick one of these on here and the problems, of temperature throttling is solved? It's not really a problem in my system though, because if I'm doing a benchmark, I crank the fan to high from the factory default of standard or optimum. And that means I have adequate airflow even when this is laying down the motherboard to do a sustained like ATTO disk bench without thermal throttling. So it's really not super important in this system, but I am experimenting with 1U and other form factors where it is pretty dense in there. And these ceramic plates that are very kind of chalky feeling, like scratching fingernails on a chalkboard, not pleasant to touch. They intrigue me on what this company has done here. Not a particularly affordable device. This is hundreds. Okay, but we do have a fan as well. So yeah, I'm naturally curious about that. All right, well, I'm not going to commit to stickers just yet. Okay, I'm done. I will say that there's a little bit of play here. That's so close to flat, I really don't suspect that's anywhere near an issue of something becoming disconnected. But it is a little bit odd that the design has a gap there that allows for that play. Now this one looks like it's screwed down on top of the 950 a little bit. In other words, I messed up. So I'm going to fix that right on camera here. So I like the design where it's simple, but let's make sure this is pushed in all the way. So these feel like a little tighter than I'm used to. And now you can see metal all around there. Now this should seat itself properly. So in my haste, I may have misassembled that very first one. Okay, well, that one looks like it's actually tightening on the M.2 itself. And just moved a little, and now it's just like all the others, free to move. So that means I'm able to tighten this a little further. All right, I'm done there. So the design, you can see, gives some breathing room between the SSDs. That's a good thing. So I like what they've done with the posts. Now it'll be interesting to see how this fan works. Let's have a look at that fan. It's blowing some air on this side and some air on the other side across this controller, but I'm not sure how much air gets to this M.2 device, which is actually my hottest one. So I may have picked kind of the worst spot for that from a cooling perspective. All right, so testing all these and hammering at them, that's probably gonna have to wait for another day because I actually have a trip coming up, so I can't really mess around too much tonight, but it's gonna be more complicated to produce such a video. But what I should do is at least get this thing powered up for you so we get an idea of the fan speed. So I imagine this tiny little fan is going to be on the noisy-ish side. So let me go ahead and put this in this system. Okay, I'm taking it out of fast forward mode. I'll just point out on the Xeon D Super Server Mini Tower chassis, you want to back out that screw. It makes it easier to put PCI devices in and out. I've done that with RAID adapters, fiber adapters, and so forth. So this is on the long side, but it does clear. Obviously I was able to fit it in without removing the motherboard. It took a lot of, well, a bit of jiggling. I imagine I'd get much better at installing the second one now that I kind of know the route. Basically, you put the fan in first, shove it towards the front, and get the whole unit in place, line up PCI, and slide it down. Now, it felt like it went in, but I don't see those pins looking all the way in. The back plate has not been tightened yet, so now's the time to do that on film. And there you go. You just saw it finish shoving in, and now I can go ahead and finish tightening the screw that's holding everything together. All right, that screw is barely doing anything. There's quite a bit of friction. I would say it's a nice tight fit, which is rather reassuring. So that's it for assembly. Let me grab a power cord and we'll hear together. Okay, the system's set with the default fan profile, but it's always louder when you first plug it in. Machine is done with its power on self-test. It gets quieter, like most machines do. The IPMI figures out it's the thermals, and then it starts to hand off to the OS, which in this case is going to be EZDIY 6.5. But my impression is I'm not really hearing this fan on the right. So it seems to add very little, and I do feel the air. Very laminar flow, straight down. I actually feel cold air right at both SSDs. So I'm surprised given this block would seem to be blocking the fan, but I can feel it. So when I put the side cover on the system, just any moving across this side of the motherboard is a good thing. Let's have a look at the back. Alright, you can see they've offset the PCI so that it's right in the middle, so there's air that can be allowed out both sides of this backplate. Okay, so now that the system fans settled down, I am noticing that, yes, this NVMe cooling solution does add some noise. To be honest with you, if you have SSDs you're not banging away or benchmarking, and you have adequate airflow in your case, it's possible you don't need those ceramic devices that they gave me to plug onto here on the controllers. Not sure if they have permanent glue, if it would ruin your stickers, or have any warranty effects. No idea. The other thing you could do is, if you really do seem to be running well, like maybe a Samsung 960, which are coming out, the Pro and Evo, have cooler running controllers. So maybe they don't need anything fancy for cooling. And maybe this voids the warranty, what I'm about to suggest, but you could try running with this fan header pulled off. .44. About a 16 decibel rise. So yeah, that fan's making some noise. Put the lid on, of course, it's going to be dramatically reduced. All right. So there you have it. I'm not saying one product's better than another. I showed you vastly different products today. Each is a different approach to adding M.2 storage to your compact system. So I'm on a Supermicro super server, and it says entering setup because I hit the delete key. I want to check the BIOS. I want to check the boot order. So all NVMe devices, it'll see with UEFI on in the BIOS, which is already on. It'll see anything that's on there, including Windows, which I don't want to boot right now. I need to boot EZDIY, where I can format as VMFS all the SSDs and kind of take a look, to just make sure they're all seen. So this is just going to be a quick test. For speed reasons, yeah, you'd probably want to put Windows natively on there and then test all four, but I don't have that luxury right now. I have a VMFS EZDIY file system on there that I'm not prepared to nuke right now. So let's go to boot order. UEFI on, USB key first on the list. That's a good sign. And I don't even want Windows Boot Manager to show at all. So I should be okay since the USB key is first. So I'm going to hit F4 and let's see how it goes. Not so well. Okay, let me go check on what USB device is inserted on the system. Be right back. So yeah, it looks like I did not have the USB media inserted in the system, so it didn't have a prayer or a chance of booting off the EZDIY hypervisor. I'm going to leave this video a little rough like this because folks have asked me, how do you set up boot from NVMe? Well, on Supermicro, you just saw when your BIOS has NVMe booting ability, UEFI needs to be turned on, and you just saw where that is set. And then any instances of Windows you have or potential targets to install Windows on or another operating system will just show. And whether that's 1 or 5 NVMe devices, they're all seen as equal partners. I suspect that at a later date, when I get Windows installed on probably on a 2.5-inch SSD, I'll boot from that, and then I'll put one of the NVMe devices on the motherboard and the other 3 on the add-in card. And that'll give me a chance to see if there's any difference in performance. But all of that won't really be necessary if it seems to perform at full speed when they're on this PCI slot. And because it's a by 16 card, the fact that each wants 4 lanes, there might not be any speed degradation. But I want to test all that to be sure. In other words, using multiple NVMe devices at once will tax the system a bit, but the PCI bus should be able to keep up. Okay, by the way, I'm using HTML5 UI rather than the Java-based one, and it's a little awkward because we can't see the bottom of the screen. If we go full screen, now we can see F2 and so forth. See how that's working. All right. Let's reduce clutter, get rid of those windows, and fire up EZDIY host client, which basically means we point our browser to the IP address or name of that server. And I might be having a problem. Let's see. Nope, it has a lease, has an IP address. Okay, looks like I probably just have a bad shortcut. Not too worried about that. Let's do this. XD. Okay, there's the name of my EZDIY host. Okay, EZDIY host client. Click on the shortcut. That's basically just Chrome browser. Just a special shortcut I made so it looks more like an application. And we'll be able to have a look at storage. Okay, devices list looks promising. USB in all of the drives. Nice. I'm pleased already. That was pretty simple, right? It just worked. That's what you want. So if we say new data store, do a silly name like that. All right, they all have file systems on there or something, so a little more work to be done. Interesting. I should have showed you data stores. And what do you know? So one of the SM951s is already formatted and has some data and is all set. So that just, shows up. There's still 2 more to go, though. It's got VMFS as well. And this one has a very sloppy looking partitioning because, well, there's Windows on there. Okay, VMFS 6, the new one. Success. Let's head back to devices, the last one. So one we just added. So we got this problematic one, and we don't know which of the two is actually seen as a data store already. There it is. Of course we do. Just have to look a little more carefully. So now if we sort by capacity, we can see that for whatever reason that one was formatted using a little less than full capacity. I sometimes do that when I'm trying to make sure I don't accidentally fill an SSD and potentially impact its speed. So the VMFS is old on that. So let's get rid of this. I'm in a lab, there's no important data on there. You want to be very careful when you do this stuff. So did it complete? Not actually seeing that show in recent tasks, which is a little bit weird. Auto refresh is on. All right. Well, let's try going to the host. There we go. It just wasn't done yet. I was jumping the gun a bit. And new data store. Now, because they have serial numbers, that might be a smarter move as far as naming. It warns me I'm about to nuke all the data. Am I really sure I want to do that? And so forth. All right, and remember this one. Let's have a look. Data store browser. Is there anything of importance on there? Yeah, 1 VM. So what? I got more like it. Not too worried about that. So let's see if I can clean that one up as well. It might complain because there's a VM. It's backing storage of one of my VMs. Okay, I'm going to leave that alone because I actually need that VM for a demo I'm doing in a couple days. So, all right, that's a VM I can vMotion among the different storage units and test for speed. So the point is the device worked. It saw all the data stores. In fact, while I'm gabbing away here, I probably should just boot this thing up. And okay. So removing the data, never mind, that's an old message. So it's booting right up, and it's booting off of, well, NVMe. And at least now I can just kind of run this, not kind of run this, I can run this and just get an idea of the speed. Let me let that finish booting. And while it's finishing booting, I'm going to just mention VM options. Looks like this guy is set to synchronize guest time with host. Huh. All right. Its time zone must be set off. Doesn't really matter. Let me go ahead and run ATTO dispatch to give you some idea if a Samsung SM951 is performing at the level we would expect. There goes the blur. You're going to want to do that if you're into this. And I can go ahead and make sure that this thing doesn't start downloading Windows updates or something right in the middle of this, disabling the network adapter. How am I able to do that? Well, we're controlling it with VMware's UI. It doesn't need a network. For that, it's out of band, kind of like a crash card for a data center. All right, so the CPU settled down. It's not able to hit the web. Now's a good time to run ATTO. And I'll be right back after the run is finished. And I'm actually going to dig up a picture of I think I have a screenshot of what the performance is supposed to be for an SM951 from within ESXi 6.5. We'll be right back after this is completed. Okay, it's finishing up. No speed degradation. You would see thermal throttling would mean this green line would sink. And I do have an article where I gave a baseline of what it's supposed to look like. So that's what it's supposed to look like, a Samsung 950 Pro and a 950 and an 850 Evo. Okay, so this one, the middle shot, is the one that I want you to pay attention to. And the verdict is looking good. That performance is unaffected. I think I'm really already done. I mean, okay, fine. Later on, I got to put a Samsung 950. Copy or vMotion this over, right? I don't have VCSA up, but I would if I could just move it over. So I got to rebuild VCSA, move it over, and run it again. And guess what? I'll bet I'll get the same exact speed, which tells me everything's fine. What would be interesting is, run some kind of benchmark or run 4 VMs, each off of their own NVMe, all on this PCI card, and see if they all perform okay. Gets a little trickier though, because ideally you want to compare that to one on the motherboard and one in a PCI slot compared. Which every test previously I've done is full speed, but this new device, well, it's different, right? It's obviously multiplexing in some way. It's dividing up for 4 devices. Because the PCI bus width I talked about, though, it should not be a problem. Well, that was a little confusing and kind of roughshod. First stab at a first look at some devices before I hit the road shortly and get in a plane. Give you a sense of, options. There are more and more NVMe options out there, and those options are only likely to further grow over time. So hopefully you found this video helpful, and thank you for watching and for visiting tinkertry.com.